rationalizing. And that's how you get that radical out of the denominator. Okay? We'll talk about this chart in just a second. So for radical 5 divided by 2, according to my quotient property, that tells me I can rewrite this as radical 5 divided by radical 2. Uh-oh, radical in the denominator. We cannot have that. Okay, so we know what to do. We know that we are going to multiply by whatever the radical is in the denominator. Radical 5 times radical 2 is just radical 10. Radical 2 times radical 2, if I multiply those guys, I get radical 4, and we know radical 4 is just 2. So my answer is radical 10 divided by 2, which is simplified because 10 doesn't divide into any factors that you can take the square root of. Now the only thing that we're going to do now is we are going to call that radical that we multiplied to get it out of the denominator, we're going to call that the conjugate. Okay, the conjugate, if you have just a single radical by itself, the conjugate is just that radical. Now let's say we have an expression. We have 7 plus radical 2. The conjugate of that is going to be the opposite sign in the middle. So let's do this example. Slow start one. All right. So we have 3 divided by 7 plus radical 2. If I want to get that radical out of the denominator, what I need to first think about is what is the conjugate of the denominator. 7 plus radical 2, I can go to my handy-dandy chart here, I have a positive sign, so the conjugate tells me I need a negative sign. So that means I'm going to multiply the top and the bottom by 7 minus radical 2. Again, the only thing we're changing is that sign in the denominator. And this only happens if you have a number plus a radical. If you had, let's say, 3 divided by 7 radical 2, then you would still just multiply by the radical. This, with the opposite sign, only happens if you have something plus or minus a radical. Okay, so now we just have to multiply our fractions. We have 3 times something in parentheses. We know we need to use the distributive property. So 3 times 7 is 21. 3 times radical 2, negative radical 2, excuse me, is negative 3 radical 2. 3 is different than radical 2. They're different terms. I cannot combine them. I could not say radical 6 because 3 is just a number. So it's got to go in front. Now for the bottom, I have 2 expressions I'm multiplying together. We know how to do that. We have a term plus another term, so we're going to use foiling. Okay, when you have a radical, it's almost like it's a variable because it cannot combine with other numbers. So we're going to multiply our first term, 7 times 7, we get 49. We're going to multiply our outer terms, 7 plus negative radical 2 gives me minus 7 radical 2. Inner, 7 radical 2. And last, we get radical 2 times negative radical 2 is just a negative 2. Oh, look what happens in the middle here. We have a negative 7 radical 2 and a 7 radical 2. Those guys are going to cancel. That's why you multiply by a conjugate, because it will always make the middle terms when you FOIL cancel. So we are left with 21 minus 3 radical 2 all over 49 minus 2, which is 47. And I'm just going to leave my answer like that. We do not want decimals here. We want to leave it in radical form. Okay, the very last thing that you guys would deal with is solving a quadratic equation. Sometimes you don't have to factor it. Let's look at this one here. We have 3x squared plus 5 equals 41. I have no x term. So I'm not even going to bother with graphing or factoring or all of that mumbo jumbo. We're just going to solve it algebraically. We only have one variable, and we know how to get rid of a squared sign. Okay, so we're going to go through. We get 3x squared equals 37, I think. 36. 3x squared equals 36. We're going to divide both sides by 3. We get x squared equals 12. Okay, now you guys know what to do here. We want to get rid of a squared sign, so the only thing that you can do to get rid of a squared is to square root both sides. We are left with x equals plus or minus the square root of 12. Now that's a pretty big radical. It's not huge, but we have to check and see if we can rewrite that using those two factors. So we get x equals plus or minus 12 divided by 2. Well, 2 is not a perfect square. It's 6, so those aren't perfect squares. What about 12 divided by 4? That's definitely a perfect square. So I'm going to rewrite that into 4 times 3. I'm going to simplify a little bit further. I can take the square root of the 4, so that goes out of my radical side, and as I pull it out, I square root it. So I get plus or minus 2 square root of 3. Now that is a pretty brief lesson on radicals. You guys are going to do more practice in class. Please bring all of your questions with you, and don't forget to do the quiz after this lesson. Thank you.